While we're still at the beginning of our discussion on functions, we want to take just a minute and talk about function notation. So I'm going to go ahead and put the slide up that we began the last presentation with, where we had our definition that said a function is a rule that relates two sets of numbers. Recall that we talked about making a table of values where we chose the x value and then we plugged in for the y value. So what I want to introduce here is that the notation that we typically use for a function is a little bit different than what we did in the last presentation with the x and the y. So specifically, what ends up happening is that the y is normally written as an f of x. And so I'm going to go ahead and somewhere off to the side make myself a note so that I don't forget that f of x is the same as y. And so when we write a function, we don't normally write that function y is equals to 3x plus 5. We would typically take this function that we have here, and we would normally see that function written as f of x is equal to 3x plus 5. So typically when you are dealing with a function, you're not going to see a y, but in place of the y, you're going to see f of x. All right, so let's look at an example. And if you'll notice in this example, the function itself is named something other than f of x. And that's okay. We're not limited to only having an f to stand for the function. Our function notation can indicate a function for any letter that we have. So it could be g, it could be h, it could be s, it could be k, right? But as long as it's of that format, f of x, g of x, and so forth, then we can assume that we have a function. So this problem says that for the function g of x is equal to 2x squared minus 3x, we want to find each of the following. So what you want to keep in mind is that your typical format is going to place the x value inside the parentheses. So when I look at the first part of this problem, whatever is in the parentheses is going to be played by the x. So if I have g of 3, then what I know is that the 3 is equal to the x. And so what I'm going to do to work the problem out is I'm going to go to my function, the 2x squared minus 3x, and wherever there's an x, I'm going to put a 3. And then I'm going to work it out. So remember your order of operations. Remember that your exponents come first. So we're going to square that 3 first. That'll become 9. So 2 times 9 minus 3 times 3. So 2 times 9 is 18. 3 times 3 is 9. 18 minus 9 is going to give me 9 for my first answer. Okay, so now we're going to do it again for g of negative 5. And so again, we want to remember that the position of the x inside the parentheses tells us that whatever's inside the parentheses is going to play the role of the x in the problem. So I'm going to write down my equation, 2x squared minus 3x, and wherever there's an x, I'm going to now put a negative 5. And again, we'll work it out. Exponents first. So negative 5 squared is going to be 25. So we've got 2 times 25 minus 3 times negative 5. So 2 times 25, we know that that's 50. And then negative 3 times negative 5 is a positive 15. So we add those together, we're going to get 65. Okay, so now we'll move to our next one. So our next one says that we want g of x, plus g of 3. So let's kind of take this as two separate problems. Let's first deal with the g of x. Now that part is actually pretty easy because we already know up here that g of x is equal to 2x squared minus 3x. So I'm going to go ahead and plug that part in. 2x squared minus 3x. Now that's the g of x part. Okay, now I need to add on the g of 3. Well, we've already calculated g of 3. That was the first problem that we did, and we found that to equal 9. So all I'm going to need to do is add on that 9. All right, so let's look at our next one. Our next one says that we want g of negative x. So again, remember that the general rule is that whatever is in the parentheses is going to play the role of the x. So I'm going to rewrite my expression, 2x squared minus 3x, and wherever there's an x, this time I'm going to put a negative x. And then we're going to simplify. So again, exponents first. So that negative x squared is going to become a positive x squared. So we have 2x squared. And then the negative 3 times the negative x is going to become a positive 3x. All right, now our next one has the negative placed on the outside. So this is essentially like me saying negative 1 times g of x. Okay, so we know what g of x is. G of x is our original function. So we basically have a negative 1 times the original equation, 2x squared minus 3x. And now we'll distribute that negative through the parentheses, giving me negative 2x squared. And then a negative 1 and a negative 3 make a positive 3x. All right, and then our last one. Our last one says that we want to find g of x plus 3. So again, remember that whatever is in the parentheses is going to go in for x. So when I write my function, I've got 2, and when I come to the x, I'm going to substitute in x plus 3. It's still squared, minus 3, and then I have another x that I'm going to be substituting in for. So again, x plus 3. So make that substitution. Wherever there's an x, you're going to put an x plus 3. Okay, so let's get the simplifying done here. Again, exponents first. So remember that x plus 3 squared is really x plus 3 times x plus 3. So foiling that out, x squared plus 3x plus 3x plus 9, and we can combine those middle terms. All right, so I'm going to come back down here, and I've got a 2 on the outside, and then I'm going to substitute in my simplified version of x plus 3 squared. So that's going to be x squared plus 6x plus 9. And then I have 3 times x plus 3. So my next step will be to distribute the 2 and the negative 3 through those parentheses. So I've got 2x squared plus 12x plus 18 minus 3x minus 9. And then we'll do what we can in terms of combining like terms. So there's not much I can do for the squared term, but I have a 12x and a negative 3x. That's going to make a positive 9x. And then I have an 18 and a negative 9, which will make a positive 9. So our final answer will be 2x squared plus 9x plus 9. So again, the thing to remember with function notation and with a problem like this is that whatever is inside the parentheses, you're going to plug in for x and then simplify.